We're now going to take up the pointers in the root equations problem. So I will first of all, okay, so as always we can go to, so again, so that, remember we have our website, please use it. I know some people do, some people are still not. Please remember to do the homework too. Okay, we're going to C programming, right? So now we are I want to take up, we've done pointers, so we're going to look at the code. We went from variables to pointers.c on each of these. Okay, so the code that we looked at converting before was R5 variables, so we should now have R6 pointers is available. Okay, so I think I'll go through the PowerPoint rather than going through the main thing, going through by code. Okay, so get rid of this thing. Okay, so I will download. So download, open, demonstrate. Okay, so again, we've been building the program to do square root finding. And what we want to do now is to use pointers so that I don't use get float prompt. Get float prompt, I would suggest you, if you want to use in the future, you can copy that because it's a safe input routine. Okay, which means it checks for errors. All right, so this is basically the example. You are starting from this code, and we wanted to replace the get float prompts with our own functions. Question? Question? Yes? Question? Can I ask? Okay. Well, you're ready to ask it all quiet. Okay. All right. So write your own function. One call. Include prototype call definition. Use scanf, printf, and pointers. So there's my prototype. Get xxsb, double xs, double xb. Okay. So if I'm doing that, I'm basically replacing these three lines. I'm not touching anything else in the code. Okay. I'm only touching the input part, so I only want to get rid of this guy, and this guy. So I then can work to modify the code, which is what you were doing for your homework. Okay, and then hopefully you came up with this sort of modified code. Okay, I do not show C mean and equation because they're not changed, but you can see how the get flow prompts have been replaced with get xs xb, which gives the address where it wants to put the information. Then I have my function that prints the standard out, xs. It gets from standard in, s. It prints. Again, note these are both pointers. Okay, so they hold address. They can hold address there. So I'm transferring an address to fscanf an address. Okay, let's look at so we can run the code and. Yeah, yes? Question? No? If you have a question, can ask. Okay, so here's our information for the human reader. There's the information for the preprocessor, where the function prototype for fprintf is located. These are the functions in this file. And then function main starts. Okay, declare 4 containers of type double. So for floating point containers, 4 of them are contained. I call get xssb, I'm giving it 2 addresses. So get xssb has repaired 2 pointers, one s, one b, and the pointer s returns gets the address of xs. The pointer b gets the address of xb. So it means that s is pointing at xs. B is pointing at xb. Okay, it has no variables. It then prints to calls fprintf. Okay, fprintf basically it has it receives a pointer. It prepares 2 pointers, only 2 pointers because there's nothing. I'm not giving it anything. One pointer is pointing at standard out, which is the monitor. Okay, and the other pointer is pointing at what you want to print to the screen. Okay? It then prints this on the screen, XS. fscanf is then called. It also has 2 pointers. It prepares 2 pointers, one to point to the keyboard, standard in, because I gave it standard in, so it's going to point to the keyboard, and the other to point to the format of what it's supposed to get. It's supposed to get one floating point number, and it's got a third pointer, though, to S. So it receives, so in other words, it's going to, if S is pointing here, so it's going to point to the same place as S is pointing to. I type in 1, and it puts 1 into XS. I print again, call fprintf again, same thing happens, and I put XB. I type in 2 on the keyboard, and basically the pointer is pointing here, so the 2 now comes in and is stored in XB. You will notice stored as a floating point number. I only type 2, but it's stored as a floating point number. If I had, it would be okay. So it's stored as approximately 2, so not necessarily 2. Okay, now CMean is called, calculates the mean, equation is called, calculates, does the calculation, and finally I print, fprint is called and prints the output. Okay, and we return 0. That's it, and that completes our analysis of code. Okay. We'll now move on. So I've taken up homework. Let's now start to go to our topic for today. Why don't we first go to, so we'll go to our main page, and I suggest, I'll let everybody also download the PowerPoint at the same time so that you also have the PowerPoint on your computer if you want to check anything. Okay? So just download this guy. Okay, and I'll let you and I'll release the screen to you guys. Okay, so please go and download the PowerPoint.
Okay.
Okay. Okay, let's continue. I think, okay, let's, I will take back control of your screens. Sorry. Okay, so as we talk about program flow, we have sequence, decision, and repetition. In the next short while, I want to talk about these 3 constructs. We'll review them. We'll talk about why we need them, our motivation, how do we implement them in C, and we'll apply to our 3 problems. So, okay, let's first of all start by reviewing the UML. Okay, we've studied in UML basically 3 constructs for algorithms we are concentrating on. There is sequence, decision, and repetition. Parallel is a different course. You can do parallel in C using the POSIX library, or is one possible way of doing parallel programming in C. So, but it's not part of this course. Okay? So we start to the end of a program are just composed of these three types of operations: sequence, decision, and repetition combined in different ways. And we can program anything with these three things. Okay? Sequence, the function start runs from the start to the end. Each line executes once, which is all our programs so far have been this way. All our programs are using sequential logic. We're not using any other structure yet. The second type of structure is decision. Our function starts to run. Based on the data, only part of the function is used. The other part of the function never runs. So, and then we come and we merge back together. But you can see here, this part of the function will never be used. Only the half, only part, because of our data. Okay, and then though that's processed, and then we continue. So this could have something here, or it could be a blank, right? It would just go straight through if nothing's happening. The third structure we've looked at has been repetition. You know, our function starts to run, and it starts to loop. It goes through, based on some condition, it runs through again, and it runs, and then finally when the condition is false, it jumps out. So as long as the condition is true, it keeps looping again and again. So as long as it is true, whatever we test is true, it will keep looping. If it's false, it will not. So generally, in this swing, we should label this output as the true condition. That's the bet. So label this output as the true condition. Okay, and then the other, and if it's not equal to that, it will go another way. All right, so these are our three constructs. And yeah, thanks Raheem for making this nice animation and make it look sort of nice to bounce around. Okay, and you can see how our stuff is sort of slowly working our way through. Okay, yay, okay. All right, why do we need these? Why do we need decision, sequence, and repetition? First of all, sequence, we carry out tasks. We do calculations. We call functions. For example, y equals 0. Print y. We're calling a function to print y. We're doing a calculation. We're making y equal to 0. It's a task. Why do we do decision? For example, the root finding for a quadratic equation. Y equals ax squared plus bx plus c equals 0. We know the solution is x equals minus b plus or minus b squared minus 4ac. Now, if b squared minus 4ac is greater than 0, we use d equals b squared minus 4ac and take the square root. Otherwise, we do the opposite. We do 4ac minus b squared and then take the square root, right? And one has the I in front, is a complex number, and one is a real number. Okay, the optics code. We're going to see why we need it in the optics code in a minute. And, okay, we'll find out that problem. That's why we need decision. Why do we need repetition? Okay, our optics code needs it. We want to do multiple lenses. I mean, the code we have, if we write a code for one lens, it's pretty useless. We need to be able to do multiple lenses so that we can design it like your iPhone has 11 lenses in it. Okay, so it's a series of 11 lenses to focus onto the thing. So how does the goal is there when you're doing iPhone design is how do I make the lens as small as possible and get as much light in as possible? Okay, that's the goal. Following objects. We have a lot of data. We would like to read all the data from a file and calculate without having to start the program again and again. For the root finder, having to type in XS, XB all the time, that's the computer can do. It can slowly narrow in and find the root, rather than the user adding more and more guesses, getting closer and closer. That's why we need repetition. Now, how do we code? The third step. Sequence, decision, and repetition. First, we're going to look at how do we decode decision. Okay, let's assume this is my UML. I have some data coming in, and I'm going to make a condition. If A is greater than B, let C equal A, and then continue on. If it's not true, then I want to put the value of B into container C and carry on. So C will hold the biggest value. So in other words, this is finding the maximum of A and B. So C is going to, this function basically says, okay, which one is bigger? We put that into memory location C. So this is maximum, a maximum function. All right. And here would be this, here's this example C code, a complete running C code for that. If.C, okay, integer main void, double, for example, whatever we want, A, B, and C. If A is greater than B, okay, there's our condition right here. Curly brackets, C equals A, semicolon, curly brackets, else, curly brackets, C equals B, semicolon, curly brackets, code is finished. So there's just the if. Now, if you look at this and if you know JavaScript, it looks the exact same thing in JavaScript. There's no difference in JavaScript than C. Exactly the same. With the curly brackets, with the semicolons, everything exactly the same. All right. So with this code, let's try to understand it a little bit more detail. Let's walk through it. Okay, the analysis. Okay, we start integer main void, double, okay, A, put the value of 5 into A, container A, the value of 3 into container B, and don't do anything with container C. Now, if A is greater than B, okay, is A greater than B? Yes, it is. So in this case, I'm going to take this root and make C equal to A. So the first condition is executed. And the value of A, container A is put into container C. And we then jump down to return. Okay? We skip, do not do the else statement. Okay? The else statement is skipped, we return. Okay. Now let's ask ourselves a bunch of questions. What is the decision format? What conditions can we test? How do we handle multiple simultaneous conditions? And what about multiple paths? Okay, basically 4 different variations that we need to worry about. Okay, first of all, the decision format. If some condition in brackets that has to be true or false, this has to be true or false. Then we have curly brackets, and then we can put as many statements as we want. Then we have a curly bracket, then we have else with another curly bracket and a whole bunch of statements to execute if this condition is false. And we execute all these statements and end. Only one of the 2 are done. You will never go both ways. Only one is done. So no. The condition must be true or false question. You can't have 3 things coming out. It's got to be a true or false question. So next question is, what conditions can we test? We can test A equals B. No. A single equals means put the value on the right into the container on the left. Example, A equals B would mean put the value in container B into container A. That's not a condition. Okay? Putting the value of container B into container A. If you want to check for equals, you have to put 2 equal signs. Okay? This is a condition now. If A is a condition, it can be either true or false. A double equals B can be true or false. Next. B not equal to A. Okay, that's the opposite, right? I'm trusting B, A equals B is one side. B not equal to A is the opposite side, right? Opposite, right? Okay, I'm testing the opposite. So in other words, I could put A equals B on this side. It's the same as putting B not equal to A on this side. I could write A is less than B, which is the same as putting B greater than or equal to A, right? If I could put A less than B on one side is the same thing as B greater than or equal to A. So I could put those both on the same, either on the same side, either write it either way. A less than B or B less than or greater than or equal to A. Personally, I prefer just to use this way because it doesn't have two symbols together. I prefer to just use the one symbol. Or you could write A greater than B, what I've done here. It would be the same as writing B less than or equal to A on the same side, right? So we can write any of these conditions we can test. These are the key conditions that we can test. Now, the next question you might want to ask is, what if there are multiple conditions? What other special symbols do we have? Okay, this, remember I told you can't use this for pointers. One symbol, one ampersand is a pointer, right? This is called English note. This thing is called an ampersand. This thing is called a pipe. This thing is called an exclamation mark. All right? So ampersand, pipe, exclamation mark. Okay, so in this case, 2 ampersands means and. 2 pipes mean or. Okay, so 2 ampersands mean and. 2 pipes mean or. And this guy means not. So these are the 3 other logic operators that we need to know. So this completes this whole set of logic operators. So I could write, if A is less than B, brackets, and B is less than C, do this. So in other words, this must be true, this must be true, then I will do whatever's in my action. So this would have to be true, this would have to be true, then if they're both true, I will do that what's action. Or I could write, if A is less than B, pipe, or B less than C. So if A is less than B, I will do it. If B is less than C, I will do it. Only if A is greater than B and B is greater than C do I not do this statement. Okay? And finally, there's this guy. If not A less than B, this just inverts this guy. So instead of A less than B, not A less than B means that B is less than or equal to A. Right? So this means B less than or equal to A. It flips the thing around. I don't know why you would write it that way, but you can. All right. What about multiple paths? For example, okay, I have a decision. I have 3 possible outputs. And I have a merge. No, you cannot do this. You cannot do this on UML. You cannot do this in C. All right? There's no 3 things coming out of a merge, and there's no 3 things coming into a merge. Okay? There's 2 things. Okay, so how do we show this in UML and in C? Well, in UML, for example, this would be an example of multiple paths. Check status. If the person is married, value times equals 0. If the person is single, then if it's not married, then check. Is the person single? If the person is single, value times equals 2. And then we merge and come back in. If he's not single and not married, check to see maybe another case. Is the person divorced? If the person's status is divorced, multiply the value times 0.05, then come back and then slowly work our way back. If none of these are true, continue on, multiply the value times 0.9, come back, merge back with divorced, merge back with single, merge back with married, and continue on. So you see how we've got, they're paired. Okay, so we split, merge, split, merge, split, merge. There's our UML. So in C code, we will now write it this way. If status equals, double equal sign, married, if this is true, value times equals 0. And then we continue on the code. Else if status equals single, value times equals 2, semicolon. Again, the close brackets. Else if status equals divorced, value times equals 2. Else, okay, if none of these three things are true, then we do this. Okay, and the code continues. So in this case, you see the format. If, else if, else if, else, and then finished. All right? Okay. So we can look at, here's a summary of it. If condition 1, statement to execute if condition 1 is true, statement to execute condition 1 is true. Here, statement to execute if condition 1 is false and condition 2 is true. Statement to execute if condition 1 is false and condition 2 is true. Else is a statement to execute if everything is false. So everything comes out false, we execute the else statement. So that's how we will handle multiple paths. Okay. And here's another, there's an alternate way we can do it. This, in some cases, we can use this other method. Not always. So please, but if you read code, you need to be aware of this. Because you will see this in people's C code. If you're writing your own C code, don't bother using it. Okay? But if you're seeing somebody else's C code, sure, you need to be able to understand what the C code is, what it's doing. Okay, this is switch condition statement. So switch, and you have the condition 1, a condition. If the condition is result A, result B, or default. So going from this one, we would then check the condition with the switch container. So my condition is basically status. I just write status, and it says, is status married? So okay, it has only limited usage. You do not need to ever use it, but you should know it if you see it in others' code. All right? Again, this is my caution. I don't expect you to use it. All right? And there's how I would write the code for this guy using switch. So switch status, if the status is married, single, if the status is married, if status equals married, do this. If status equals single, do this. If status equals divorced, do this. Otherwise, else, do this. Okay? So this is just an alternate way of doing it. It's called a switch statement. And now we're going to start to apply it to the optics program to fix the Gauss's lens program. So if we're going to move back to, in your book, it's page, we're going to work on now, spend some time working on page, okay, maybe I shoot right back to my, okay, page 25. Page 25 in your workbook. Page 25 in your workbook. Okay. Go to page 25. It should be page 25 in your books. I think, okay. Page 25. Where did my 25 go? No. Not page 25? No, it's not page 25. Okay, it's page, where is my optics guy? Optics. Sorry, page 20. Looks like it's page 28, right? 28, 20. No. Where did I go? 38. 42? Should be 42 then. Okay, let's try 42. I seem to got all my pages mixed up. Where did he go? 42. Here's 40. Okay. Okay. Yeah. 42. Sorry, 42. Yeah, 42. Sorry, forget that. My mistake. Okay, yikes. How did I make that? Okay, my mistake. Okay. Sorry. I'll get that corrected. So go to page 42, not page 20. Okay, enable editing. 42. Okay. Oh, I already saved it, didn't I? Okay. Oh, it's in the download guy. Oh, good grief. Okay. All right. Close that guy. Hopefully this guy. No, not this guy. Okay, so you should hopefully. No, not that guy. Okay, anyways, okay. We are going to try to correct the optics code. Okay, so let's go look at. I want you to go to our main page. You will. I don't want us to start from. I want you to first download this guy right here. This code right here. 06pointer.c. Okay, this code is the one we're going to be looking at. This code will download. I'm just downloading it now, and I'm going to go to Notepad. ++. Okay. Okay. Oh, where's my Notepad ++ gone? Where did you go? Okay, here we are. Get rid of this guy. Okay, so there's our code that we're running right now. File, save as, 06.c, okay, 06ptr.c, okay, save it. Okay, and now I want you to, you're going to run it for these two cases here and look at the results. Okay, download and we'll run it. I'm going to, okay, all right, so please do that. Download this code and do the same, see results, and then we'll just, once you've got those results, we'll look at and see the problem we've got. Okay, so download 06 pointers, make sure it's running okay, and fill in the table, try to draw the picture of what you see here. Okay? Okay, so make the small corrections to get the program running first. Okay, you should be able to, there should be a couple of things that you need to fix, I hope. And you'll be able to fix them, I am sure. So correct the two errors. You should be able to, I think you probably see where they are. They're quite common mistakes. Okay, let's come back. Let's continue on. I'm hoping you found the error, I'm sure. Find the errors in the program you've corrected. And hope at least some of the errors. All right. Okay, let's continue on, guys.
People from this side figured it out.
All right, let's continue on. Okay, all right. So, hi guys, okay. I think most, okay, so let's see what the result, okay. So when I run the program, okay, let's head back to running the program. Okay, once we've corrected all the problems, right, 06PTR, oh, 06PTR, okay, position 1 is 0, height is 1, lens is 5, position 5, okay, and you can see we're at the focal point, so there's going to be no image. Okay, so we get infinity, which is correct. Okay, let's, if I put in the other one, so let's, I'll go back to, I summarize my simulation. Okay, there's what, and then, sorry, let's do the, I'll do both cases first. Okay, my other case, I put this in, my initial position is 10, height is 1, lens is in the same position, and get my image position is now at 7.5, and its height is now 0.5. Okay, 7.5, 0.5. So let's look at our two cases. So I've done my calculation. 0x, 1, Lx, Lf, and I get my object position is 5, infinity, 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 and the other guy, 10, 1, 5, 5, 2.5, 7.5, and 0.5. So in the first calculation, I got infinity. Second calculation, I have some numbers. So let's look at the case. So if I draw this first picture, how do I draw the picture? Basically, I start my guy. He's way out 0. There's my lens. And basically, you can see there's no image. These rays are not going to condense. So this is basically what a telescope is doing in the opposite direction, right? The light's coming in from infinity, the sun. We're focusing in on something at a single point. Okay, so we're at the focal point. We're focusing here. So there's no image. This is a correct calculation. Now, what I'm doing next in my next calculation is, okay, I put it on this side, and I get an image here, right? This is telling me that the image is going to be here. So, does this make sense? No, it doesn't make any sense, right? If I'm on the left side of the lens, there'll be no image. If I'm on the right side of the lens, there is an image. So this doesn't make any sense. And if you did in Gaozheng, in your senior high school, they always put the person on the left side. They never put the person on the right side. Okay? So if a person's on the right side of the lens, that equation, what it should be, it should give us this answer. This is wrong. It should give us this, right? It should be, the image should be at infinity, just like this guy. So if on this side of the lens, the image is at infinity. When I do it this way, it should be minus infinity. Okay? So if I'm on the left side, I should get infinity. If I'm on the right side, I should get minus infinity. Because it's symmetry. Okay? So the code has some problem. Alright, so we saw two types of errors. One is you're just typing error in C, which is easy to correct. This is logic. So this is a logic error. And now we have to think about why we have a logic error. Okay? When do we get the logic error? So, first of all, this is correct. So we can say that when the person is on the left side of the lens, we get the right answer. When the person is on the right side of the lens, we get the wrong answer. Okay, so when the object is to the right of the lens, O is going to be less than 0, right? O is less than 0. If O is less than 0, I is calculated wrong. Okay? When O is negative, I is calculated wrong. So we now have to try to think about how to fix it. Our first job is to look at this equation. Okay. I equals OF, O minus F. Here's a few examples. We get some negative F times O minus F. What happens in this calculation of this equation? If we're on the one side, both O and O minus F are wrong when O is less than 0. Okay, so we see F times O. Okay, 25 versus minus 25. O minus F, 0 versus minus 10. So in one case, if on the opposite side, this O minus F gives 0, which gives us the right position of the image. In the other case, it gives us minus 10 because we're subtracting. So we have to change the equation. So it's a logic error. We have to change the equation. So we basically now have two equations we can basically use. The new equation we're going to have a new equation to be correct when O is less than 0. Okay? All right. So here we can basically put two equations. When O is greater than 0, we'll just use the standard equation. When O is less than 0, we're going to have to change the equation and put a plus sign on the bottom and a minus sign on the top. Okay? We swap the signs. So it's no longer O minus F, it's O plus F, and it's minus OF. So we now have a condition. Okay? You can think of this as a UML. So please, on your paper, draw the UML for this case. Okay? Draw a UML diagram to show how we want to do this code. Alright? So I want you to draw the UML diagram. Okay? Work on that. Think about the UML diagram for equation lens. We need a new UML. Okay? I'll just leave this on the screen because you don't need a screen. You're just writing on a piece of paper. And then we'll go together and write it together. Okay. We should take, when you're doing that, also we'll come back at 4:20 and continue. Once you finish your UML, please take break. Okay? We'll start again around 4:22. We'll finish this and then we'll have milestone. Okay? Alright, so that's basically our plan for the rest of today. So finish your UML, take a break. Okay, let's come back. Hello, hello. Come back, please. Hello, hello. Okay, let's come back. Come back. Okay. Let's now move forward. Hi, hi, hi. Hello. Okay. All right. Let's continue on. All right. So we looked at satisfying both conditions. You've drawn your UML. I think, okay, let's just quickly go through that UML. Basically, it's going to be basically a few things. We're going to have a decision, right? And we're going to have two different equations, right? And the decision, if we want to write our UML, is going to basically look like 1 here, 1, 2, out this way, okay. And in one case, our decision is basically going to be, we just have to label one n. All we want to do is O greater than 0, right? If O greater than 0, we need to take one root. If O is less than 0, we'll take the other root. So we just label one root, O greater than 0. And we use, this would be the conventional formula, I equals OF divided by, what is it, O minus F. And the other side is going to be I equals minus OF divided by O plus F. Okay, and similarly, and then we have the joining. This guy will come here and we'll join back together again. So this is basically our UML. As soon as we need to join this guy too, so debranch him, okay, they come back together again, and we probably should also have that for consistency. Let's come in from somewhere, and let's Control D, let's go shooting out somewhere. I don't care where we go. Anyways, we're going to shoot out somewhere. We're coming in from somewhere, and we're going out somewhere. And in the case when O is greater than 0, we just take this root. Okay, so that would be the UML. So once we have our UML, okay, let's now move our UML into C code. Here would be the C code. Okay, if O is greater than 0, I'll copy my UML across. And so you can see what we're doing here. We're just moving our UML here. Okay, I'll move this guy out of the way over here and put my UML. There's my UML, so you can see compare them to. If O is greater than 0, we do OF, O minus F. Otherwise, IF equals minus OF over O plus F. Okay, the else condition. So we have an if, condition is stated in the brackets, then the first condition, and then if that's not true, i.e. O less than 0, it will do the lower one. And here we are, so we want to initialize the conditional flow. We'll walk through it together. We will modify equation lens to handle when the object is to the right of the lens, and we're going to use the if statement. In other words, if A minus B, C equals A, C equals B. So we only have to modify the equation, which is not showing here, sorry. Okay, function equation is the only thing we have to modify. Okay, so still not showing. Okay, sorry. All right, so yeah, so this is the only function we need to modify, and there's how we would actually modify the equation. So we just change these two lines in the equation. So if you could, okay, I'll get 06 pointer back again. All right, so 06 pointer, let's look at him. So it's only this guy. Where's the equation gone? Oh, here he is, right down here. So it's this little function we want to modify. We don't want to touch anywhere else in the program. We only want the change right in here. So we now have our if statement goes right into here. If O is greater than 0, we use our current equation. Else, we use our new equation, which I pull my UML diagram across again so I can actually see it. Okay, there's my UML diagram. So it's kind of small, but OF, okay, minus, sorry, there should be a minus there, sorry, minus. Okay, I equals minus OF divided by O plus F. Okay, close it. Okay, that's all that's required to do. And now my function should be able to work, so I'll save it as file save as O if.c, and let's go down to my program to run it. GCC minus C. See if I have not made any mistakes. This should work. Oh, no. What have I done now? Oh, I forgot a modification sign. Okay, O times F. Oh, what are mistakes there? Sheesh. Okay. All right, that should be okay now. All right, GCC minus O, if.exe, O underscore if.o, and if I, okay, oops, don't call it if, oops. Cannot, it's a reserved name for the operating system. Windows cannot allow you use if as the name of a program. So, all right. I'll solve that problem, sorry. Okay, all right, position. Okay, let's check our two conditions. 0, height 1, position 5. Still correct, good. All right, let's try the other one. Our other condition. Position 10, object 5, 10, height of 1. Lens is position 5, focal length 5, and I get infinity 2. All right, so now I'm correct. Okay, they're both giving me images where I expect them to be. No images, because they're at the focal point. So I'm confident my equation is actually working. and I've successfully modified my code. Okay, so we run our code, and that's basically, and that brings us to the end of today's class. We will now move to milestones. Okay, if you are doing milestone 3, I will put the I will share it. I'll share the question on the screen and then close the screen, and also share it on the blackboard. Okay? All right. Okay, so if you're doing milestone 4, you will get it. Okay, so please choose whichever milestone you're doing, milestone 3, 4, or 2, I guess. Yeah.